Ben with -9 Computing, and today I wanted to talk about how DNS is incredibly important and it's a very overlooked part of the internet. Now, I love DNS, what can I say? So without DNS, the entire internet would just not function the way you would expect it. You would not be able to browse to websites, you couldn't buy things online, you'd have to actually mail letters to people, and no more Zoom meetings. Some may think that's a good thing, but I don't. You can stream music, you can do your homework, or you'd have to do it with a paper and pencil and paper. I think I said paper twice there. A lot of paper. So let's dive in a little bit and kind of understand what DNS is and why do you even need to know. So to start with, all the computers on the internet are connected into networks, and these networks communicate with each other via cabling that could go under the ocean, over land, and even satellites in the sky. So that's how they all interconnect, and that's the internet, right? Now, to identify each computer, they have to have a unique address, an IP address. It's a string of numbers, and there are a lot of numbers out there, and there's just no way we can remember them all, right? It's just way too much. So how does DNS work? Well, let's get into it. Now, when you type www.youtube.com into your web browser, what actually happens is you're looking for www.youtube.com . There's a period at the end of that. Now that period's invisible, you don't need to type it, but it's absolutely essential to how DNS functions. That dot is considered the root domain. It's the absolute beginning of the domain name service chain. So when you browse to www.youtube.com, the first thing that happens is your browser and your operating system will look and see if they have that information, that IP address that's associated with that name cached already. Now, it's not like cache money. It's C-A-C-H-E, so it's cache, it's memory. Is it stored in memory? If it is, off you go and you're done. If it isn't, there is a whole string of events that occur to get you that number. So if your computer doesn't know where www.youtube.com is, it doesn't have that record locally or cached, then it will reach out to a resolving name server. Now this resolver name server is hard-coded, or it could be automatically entered into your operating system. Your operating system asks the resolving name server, what is www.youtube.com. The resolving name server you're talking to may or may not have the information in memory. If it does, it shoots you back the answer. But for now, let's just say it doesn't know, so we can kind of go through the full chain of events. The only thing the resolving name server should know is the root. It just has a list of root servers, and that's that invisible dot at the end of the URL. So when you request your resolver requests the root name server for www.youtube.com, it'll say, I don't know, but it will say, I do know where you can find the COM name servers. And these COM name servers are actually considered TLDs, top-level domain name servers. And in the top-level domain name servers, for example, the COM name servers, your resolver will now ask these COM name servers saying, hey, do you know where www.youtube.com is? And they'll say, I don't know, but I do know where youtube.com is here. And it gives the information. So the resolver then goes to yet another server, and this other server is the authoritative name server. So the COM name server will know the authoritative name servers for youtube.com. When I say authoritative, I mean that the youtube.com name servers actually have the records www.youtube.com. How did the top-level domain, COM server know what authoritative name servers to use for youtube.com? Well, it's something called the domain registrar. So basically you buy a domain like youtube.com and you'll enter information, your name servers. Well, the registrar takes that and it sends that information off to the organization responsible for top-level domains, and they use that information to update all the top-level domains in your servers. I know the answer. Here it is. It'll send back an IP address, and we're just going to use a fake address for now, just 192.168.100.5. So that information is now cached on the operating system and in the browser, and the browser then, well, the operating system then passes it to the browser then browses to this address and gets a response back, hopefully.